Today we're looking at simplifying algebraic expressions, and in order to do that you've got to be able to identify what we call like terms. So let's take a look at what some like terms look like, okay? Now all of you know your constant terms, just numbers, you know that those are like terms, but if you have variables involved, in order for them to be alike, the variables have to be alike and they have to have the same exponents. So some examples of like terms are 3m and 2m. Those are like terms. They are like terms because we have the same variable m and the exponent for m is 1. So those are like terms. Z and z over 6. These are like terms. Now this could be written as 1/6z like that, okay? Also, and if I had 7 and 6.5, these are like terms. These are constants, and you have been able to add or subtract these since you were in elementary school. So those are some examples of like terms. Then I need to give you some examples of terms that are considered unlike terms. So some examples of unlike terms would be if I had a 5z squared and a 6z. Well, these are unlike. They have the same variable z, but the exponents are different. This one has an exponent of 2. This one has an exponent of 1. If I had a 9x and a 9y. These are unlike because the variables are totally different. And if I had a 5 and an n, those are unlike. This is a constant term, that is a variable, so those are unlike. So you've got to be able to determine the difference between like terms and unlike terms, because when we start simplifying, you can only simplify if they are alike. So let's start by see if you can identify the like terms in the list. So example 1, if I had a list of numbers, a 3x, a 5w squared, a 7x, a 9v, a 4w squared, and an 8v. Well, let's take a look at this and see if we have any like terms. Well, I have a 3x here, and the x has an exponent of 1, so I need to see if there's another term up here with an x with an exponent of 1. So the 3x and the 7x are like terms. So 3x and 7x, those are like terms. As I look at that w squared, I notice that this is a w squared, so that means that 5w squared and 4w squared, those are like terms. Well, I notice I have a v. I have a v here. Both of them have an exponent of 1. So 9v and my 8v, those are like terms. Let's take a look at another list of numbers. Example 2. On example 2, let's look at this list of numbers. If I had a 5y, I had an x over 2, a 4m squared, a 7x, x squared, a 4z, k, a 9.5m squared, a 2x, and a 2/3 y. Now let's look at this list and see if we have any like terms up here. Well, I have a y to the first here, a y to the first here, so that means that my 5y and my 2/3 y, those are like terms, okay? All right, let's see if I have anything else up here. I notice that there's a x divided by 2, there's a 7x, there's a 2x. All of those have an exponent of 1, so that means that my x over 2, 7x, and 2x are like terms. I'm just underlining so I'll know what I've already used, okay? All right, let's see if I have a like term for the x squared. I don't see another x squared term. I see a 4m squared. I see a 7.5m squared. So that means that 4m squared and 7.5m squared, those are like terms, okay? All right. I don't see a k term up here. I don't see a z term. And I do not see an x squared term. So from this list of numbers, those are my like terms. So now that we know how to identify our like terms, let's see if we can simplify some expressions. So let's simplify each expression. Example 3. If I had 3x plus 2y plus 5x. Well, in order to simplify, I first of all need to look at this and see if I have any like terms. I notice I have an x to the first here, an x to the first here, so these are like terms. When you combine, you either add or subtract the numerical coefficients. Those are the numbers before the variables. So I'll add the 3 and the 5, get 8, so I'll have 8x. There isn't a like term for the 2y, so that remains as a positive 2y. So the answer is 8x plus 2y. Example 4, if I had 4m plus 3n plus 2m. Let's see if we have some like terms. I notice I have an m to the first, a m to the first, so those are alike. 4 plus 2 gives me 6, so that gives me 6m. I don't have anything to combine with that 3n, so it remains as plus 3n. Example 5, if I had an x squared plus 2y plus 8x squared. Well, this exponent is a 2, this exponent is a 2, so that means those are like terms. Well, there is a numerical coefficient here in front of this x squared, and it's understood to be a 1. It's understood to be there. So when I add 1 plus 8, I get 9, so I get 9x squared. There isn't a like term for the 2y, so it'll be plus 2y. Example 6, if I had 10 plus 9y minus 6x minus y. Well, as I simplify, I only have one constant term, and that is my 10. When I look at my y term, I have a 9y minus 1y, so that gives me a positive 8y, and I don't have anything to combine with that negative 6x. I have two more examples. Example 7. If I had 4 times the expression x plus 8y minus 2 plus 7 plus 12x. Where you are taught to do whatever's in parentheses first if possible. Well, I noticed there's some like terms inside the parentheses, so I need to combine those first. That dash makes that 2 negative, so I have a negative 2 and a positive 7. That gives me a positive 5. Now, if you notice inside parentheses, all of these are unlike terms. So let's make use of our distributive property to clear the parentheses. So 4 times x is 4x. 4 times 8y is a positive 32y. 4 times 5 is 20. And this 4 doesn't have anything to do with that 12x, so that's plus 12x. Now let's take a look at this and see if we have any like terms. I notice I have a 4x and a 12x, and 4 plus 12 is 16. So I get a 16x plus 32y plus 20 as my simplified answer. And our last example, example 8. Five times the expression x squared plus 3y plus 3x squared plus y plus 2z. Again, let's take a look at what's inside parentheses. There are some like terms, so you need to combine them first. 1x squared and a 3x squared gives you a 4x squared. Inside parentheses, you can't add these because they are unlike, so let's make use of our distributive property. 5 times 4x squared gives you 20x squared. 5 times 3y gives you a positive 15y plus y plus 2z. As we combine like terms, I don't have a like term for the 20x squared, so I'll just keep my 20x squared. I see a 15y plus a 1y, so that gives me a 16y. There isn't a like term for the 2z. So my final answer is 20x squared plus 16y plus 2z.